Okay, so now let's apply our method. This time we've got an equation that says solve 2 times the cosine squared x, the square of the cosine of x, minus 5 times cosine of x plus 3 equal to 0 over the set of real numbers, negative to positive infinity. And what we've come to the conclusion of so far is that we've made up a method. Our method basically goes like this. Number 1, we're going to set the equation to 0, which this one already is. We want to isolate any simple trigonometric equations and then solve that equation over the interval from 0 to 2 pi. And then to each of these values, we're going to add 2 pi n to get n, where n is an integer, to get all of the coterminal angles for x that satisfy the equation. So, well, let's work with this one. We've got 2 cosine squared x minus 5 cosine of x plus 3. If we make a substitution, it might help us to see a little bit better what we're dealing with right here, especially if you're still having a little bit of trouble with visualizing factorization. So if we let u take the place of cosine of x, then the equation, the expression that we have, will be 2u squared minus 5u minus, or plus 3 in this case, equal to 0. And we may or may not right away see it, but this will factor. This will factor into 2 binomials. Our 2 binomials in this case are 2u and u as the leading term, and then we have to have pairs of terms that will add up to negative 5, but let's make it minus 3 here and minus 1. How will that work? Well, let's see. Negative 3u minus 2u will add up to negative 5u. Negative 3 times negative will give us plus 5. So that is the correct factorization. Now let's replace u one more time, and we actually have 2 times the cosine of x minus 3 times the cosine of x minus 1 equals 0. Well, we've got 2 linear factors essentially set equal to 0, so we try to take each factor, set it to 0 individually, and see where it leads. So we've got 2 times the cosine of x minus 3 is equal to 0 as one equation, and the cosine of x minus 1 equals 0 as the other. Well, if we isolate cosine of x over here on this left equation by adding 3 and dividing by 2, we end up with cosine of x is equal to 3/2. Now the problem with this, of course, is that we would be forced then to try and find our inverse cosine of 3/2. And the problem, well, that's right, 3/2 is not in the domain of the inverse cosine. And so what we would have to conclude right here is that this is going to be a part of the equation that has no solution. How about this one? Can cosine of x minus 1 equal 0? Well, yeah, cosine of x would equal 1. And so we're in essence looking for a quadrantial angle, and we know that when we set x equal to the inverse cosine of 1, we get x equals 0 as one of the solutions. But we also look at this as being an angle that is on the x-axis, and so any of our positions, our standard position angles that end on the x-axis, will also have a cosine equal to 1 or negative 1. The only other position where this is going to happen at is x equals 2 pi, if we added our coterminal 2 pi n, right? And if we look at this, it looks like what's going to happen is that we could say that x is equal to 2 pi n is our solution set, again, where n is an integer. Right? So this says that any whole number multiple of 2 pi, including 0, or negative 2 pi, or positive 2 pi, or 4 pi, and so on, will give us a cosine equal to cosine of x minus 1 equal to 0. And so that's the solution we were looking for, and we're done.